Now we are seeing the derivation of Carnot cycle efficiency. So we know from the basic principle or definition of efficiency is nothing but is the output ratio between output and input. So here we are applying this Carnot cycle to a heat engine. So we are to find out the efficiency of this heat engine when it is working on this ideal Carnot cycle. So Carnot cycle is the ideal cycle. So from for this engine we have to find out the efficiency, or by applying the Carnot cycle we have to find out that cycle's efficiency. So here basically here output will become work done and input will become heat supplied, and here work done we can write as heat supplied minus heat rejected. So if you observe this diagram, suppose the engine is working on a Carnot cycle. So from a source which is there at high temperature, we are supplying the heat Q1, and this engine is rejecting Q2 heat to seek lower temperature. So the work done is nothing but Q1 minus Q2. So you can write here work done as heat supplied minus heat rejected, and here heat supplied as it is. So Q1 minus Q2 by Q1. So here we have to let us find Q1 and Q2. So first of all, let us see what is Carnot cycle and what processes it consists. So the Carnot cycle consists of two isothermal process and two adiabatic processes, and these are reversible. So here if you see, A to B is a isothermal expansion, and B to C is the adiabatic expansion. C to D is the isothermal compression, and D to A is the adiabatic compression. And this is the TS diagram for this corresponding Carnot cycle. So here if you see, because A to B and C to D are isothermal process, so the temperature is same from initial stage to final stage. That means A and B temperature is same. So if you observe that in the TS or T5 diagram, that is TS diagram, temperature and enthalpy diagram. So sorry, entropy diagram. So here AB, from A to B is isothermal process. So if you observe here, A, B temperature is same, TA and is equals to TB, that is equals to T1, that is higher temperature, and CD is also isothermal process. So TC is equals to TD is equals to T2, that is a lower temperature. So if you see, A to B is a reversible isothermal expansion, B to C reversible adiabatic expansion, C to D reversible isothermal compression, and D to A reversible adiabatic compression. If you see here, we have to find out heat supplied and heat rejected here. So heat supplied is given by PAVA log E VB by VA. Why? Because we are finding out, I told that heat is supplied in the uh, adiabatic process. So in this Carnot cycle, heat is supplied in isothermal process, isothermal expansion, and heat is rejected in isothermal compression. So when you want to find out the heat supplied, so in the isothermal process, heat supplied is nothing but work done. So we know work done in isothermal process P1 V1 ln r log E V2 by V1. In the place of 1 and 2 we have taken A and B. So we can write PA VA log E VB by VA. So we know we can write PV is equals to MRT. So here we are taking unit mass of fluid. So we can write M as 1, and so here R and T1 and T2 are same. So we are writing some T1. So P1 V1 in the place of P1 V1, MR T1 means in the place of T1 we are supposed to write TA, but TA and TB is equals to T1. I told here TA TB same, that is T1 we have taken. So we can write in the place of TA. So actually we have to write PAVA is equals to MRTA. M is 1, so we have not written 1. In the place of M we have written 1, and in the place of TA we have written 1, TA T1. So and 2 V2 by V1 means VB by VA. So in the same way, heat rejected we can write uh, so heat is rejected in this isothermal compression process, that is C to D. So if you apply this, means in the process of C to D, if you write for the process, if you write heat rejected or work done that process, that is a PC VC log E VC by VD. So VC are at the C and D temperature is same, that is T2 you can write here. So you can write R T2 log E VC by VD. So here and also if you see for this B2C process, that is adiabatic expansion process. So for adiabatic expansion process, suppose if you write T1 by T2, so it is nothing but V2 by V1 whole to the power of gamma minus 1. So, but we are writing for B and C. So if you take B as 1, C as 2, so it is T1 by T2 means TB by TC. So you have to write V2 by V1 means so VC by VB whole to the power of gamma minus 1. So this is for process this B2C. So you can write TP by TC as VC by VB whole to the power of gamma minus 1. That is, suppose let us take it as the equation number 1. So at B we have temperature T1 and C we have temperature T2. So for the TB and TC we can write T1 by T2. In the place of TB by TC we can write T1 by T2. So the same way if you take for adiabatic compression D2A, suppose is the adiabatic compression. So for that this adiabatic process also, if you write relation between temperature and volume, so you can write like this, TA by TD is equals to VD by VA whole power of gamma minus 1. So TA in the place of TA we can write T1, and in the place of TD we can write T2, and it is VD by VA whole power gamma minus 1. This is, let us take it as equation number 2. So if you observe these two equations 1 and 2, left side is same T1 by T2 and here also T1 by T2. So this right side also will become same. So I can write VC by VB whole power gamma minus 1 is equals to VD by VA whole power gamma minus 1. So we can write this like this. So from that we can write VC by VB is equals to VD by VA, or VC by VD is equals to VB goes the sets of VB by VA. So VC by VD and VB by VA, if you see, VC by VD is a compression ratio and VB by VA is the expansion ratio. So these ratios are equal. So let us take it as these ratios as R. And if you see ratio of isothermal compression and ratio of isothermal expansion, so both are same here. C to D, VC by VD, VB by VA, same. So that is we are taking as R. So once again, if you write the efficiency formula, Q1 minus Q2 by Q1, and Q1 we got as RT1 log E VB by VA minus RT2 log E VC by VD by RT1 log E VB by VA. In the previous steps we got this. So in the place of VB by VA or VC by VD, we can write R from this previous step. So and if you write in the place of this, if you write R, and we can take this R and log E R common, and you can cancel. So remaining things are T1 minus T2 by T1, or it is 1 minus T2 by T1. So this is the expression for efficiency of Carnot cycle. So here if you observe, T2 is the lowest temperature in the cycle and T1 is the highest temperature. So so in the place of T2 you can write T lower, and in the place of T1 you can write T higher. So you can write like this also, efficiency of Carnot cycle is 1 minus T lower temperature by T higher temperature. So for more videos please subscribe and activate bell symbol, and also please share it with your friends. Thanks for watching.